If I asked you to integrate this expression, what you would probably do eventually would be to try u substitution of the denominator. And that would mean that du is 2x minus 2 dx. dx is du over 2x minus 2. And then you'd have the numerator over u times dx being du over 2x minus 2. And you would notice you'd have a problem here because this does not cancel this, and therefore we don't get our integral all with respect to u. And so we aren't able to integrate this expression. So we're going to look at another method today, and that's called integrating rational functions by partial fractions. And the goal here is to write a rational function that has a non-linear denominator, as this one does, as the sum of two other fractions that do have denominators that are linear. And if we can do that, that will allow us to evaluate these two expressions, which then would mean that we've evaluated the expression on the left. So the goal with this method is to take the expression that I have, and let's look at the factors on the denominator. If we factor the denominator, we're going to get x minus 3 and x plus 1. And then what we want to do is we want to write this as something over the one factor, x minus 3 being linear on its own, plus something over the other factor. You remember that when you studied the addition of two rational expressions, you had to get a common denominator and then you'd bring it together to get your answer. What we're doing here is we're trying to go in reverse. Take what our fraction is with multiple linear factors and break it into its separate rational functions with linear factors. So the question really is, what are the values of a and b that make these two fractions add together to give us this result? So we're going to begin by multiplying both sides of this equation by the lowest common denominator, which we know is x minus 3 times x plus 1. Multiply both sides of the equation by that. So on the left that would give us 5x minus 3, and on the right it would give us a times x plus 1 plus b times x minus 3. I'm going to expand on the right. And then what I'm going to do is gather together on the right the terms with x. So these two terms could be expressed as a plus b times x, and the constants can be grouped together. And then what we're going to do is we're going to equate coefficients. If 5x minus 3 equals what I have on the right, then the 5 must be the value of a plus b. So 5 equals a plus b. And this constant must be the value of a minus 3b. So negative 3 equals a minus 3b. And what I have now is a system of equations to solve for a and b that will give us the numerators on my partial fractions. Alright, so I'm going to take these two equations and I'm going to subtract them. So that would give me 8, which means that b is 2. And if b is 2, substituting back in, that means that a is 3. And so bringing back my original expression, I can then pop 3 into this position and 2 into that position. So let me do that. And therefore, if I go back to what the question was, to integrate this expression, I can do that by integrating this expression with a linear factor of x minus 3, plus integrating this rational expression with a linear factor of x plus 1. Now if I think of a u substitution for this, u would equal x minus 3, which means that du would equal dx. And so this expression we know would be ln absolute x minus 3 with my coefficient of 3 in front, And this expression would be 2 ln absolute value x plus 1 and plus a constant of c. And so I've integrated a more complex rational expression using the method of partial fractions.